The next challenge is misc Pike. Surely this time my calculator app will be safe. After starting the instance, use the SOCAT to create a SSL proxy to the server, SOCAT version. This was made by Clubby789. We're given an instancer. Let's start that. And we're given a Docker file and a server.py. So let's look at the server file. So we have an RPC, threaded server. The RPC is exposing 4 functions, little calculator app. Running on port 1338, and not much going on. So that's interesting. And then let's look at the Docker file. Not too much. Python, install a package, SOCAT, server, flag. It's installing a very specific version of our rpyc, so we can probably guess that there's something related to this specific version. And I think that's all we have. So the first thing to do, there really isn't much to attack. There's an RPC server that has almost no attack surface, and there's really nothing in the Docker file except for the specific version, so there's probably something wrong with rpyc. So if we Google for that, oops, already Googled it, but rpyc, cve, github, POC, and we click the first link, we can see that there is something wrong, and version 4.10, version 4.10. Cool. So it's going to be a little script kiddie exercise where we copy some POC off the internet and hope it works. Blah, 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 blah. They're nice enough to include a full POC. So we can kind of look over this. It's creating a little RPC server. And then it's doing a whole bunch of stuff. We're going to be grabbing code objects, which looks pretty fun. There's some eval function we're defining, some set attributes, version compare. They put all their code into a unit test, which I guess is good for testing the package, but we're going to kind of massage this out and get the actual exploit script. There's a lot to this exploit script. It's definitely not trivial, and I don't really understand it. To be honest, I took the script kiddie approach and just copied the code and massaged it until it works, standing on the shoulders of giants. But I think if I understand, like there's a handle, this specific handle, so there's a handle compare function, and there's no security checks on it, and from there you're kind of able to crawl up the accessor chain within Python, and then from there we can start compiling Python objects and sending it remotely over, and construct like our own execution environment remotely, where we can then inject our own eval function, and from there we can start executing code. But like I said, you don't really have to understand any of this. This is a script kiddie challenge, so we're just going to copy the code. I put it over into my solve script. So this is like if we were to use it normally, this is what it looks like. So this is just to make sure everything's working. You do rpyc connect to localhost, and then you can call these functions. So we're just calling the add function. You can see this is the exposed add function. And this is where the POC starts. Like I said, basically I just copied it and massaged it. They were putting everything in unit test. I just put everything into the top level. And at this point, yeah, I just ran it. It doesn't work. Oh, and the very last thing I changed before running it was they were doing something else. I just put a final payload that we wanted. Did the Docker file have the cat or the flag? Yeah, we already know where flag.txt is. So I'm just catting out the flag shell equals true as our final payload, because we know that eventually this will be put into an eval. Cool. If we run this originally, it was using a different version of Python, and so we have to change this code objects around. So this is how you construct these are all the arguments used for constructing code objects in Python. The problem is between Python versions, the arguments and the order of the arguments change. So we just have to change these arg names so they match Python, and we're on 3.11, I think. Yep, Python 3.11. To do that, you can do this. So you can just use the Python inspect. You just need to make sure you run this with Python 3.11, but you do full argspec of types code type, and from here we can just run it real quick. Python 3.11. I should run this in the Docker file, but we get the same thing. Argspec, and we can see these are the arguments it expects. Like I think exception table and something else changed. So you just swap those out, and then from there the POC just works by itself. There really wasn't too much else to change. And so if we run it, Python 3.11 solve. Oh, I'm not in the folder. Python 3.11 solve. Code expects most 16 arguments. Oh, I'm not running this in Python 3.11. It'll run and it prints out the flag. So pretty simple. So if we go back to our instancer, we'll do the SOCAT one. I think I have a make file. Yeah, we'll run it like this. So we're going to grab this out and put it here. So what this will do is it'll just set up a little local proxy. The challenge expects to be going over HTTPS. So with this SOCAT thing, it'll run over HTTPS. Make SOCAT. So now SOCAT is listening on port 1338 instead of our normal server. So we should just be able to run the solution. And we get an error. OpenSSL 2 parameters required. Doing something wrong. Maybe it doesn't want this verify. Oh, did I forget the port? Whoops. Now let's run it. The exploit takes a couple of seconds to run. Like I said, I think it's like rebuilding all the modules. Like if we actually look at the code, yeah, all these modules, it's like storing them locally. It's like grabbing them from the remote and then storing them locally, and then I think it rebuilds them, which is pretty crazy. But since we're script kiddies, we didn't actually look into it. We just copy code and execute it blindly, and our script kiddie ways have paid off. So PyJail with a twist. So pretty fun challenge. Yep, that's it.